So for the second part of 10.6, we are still looking at our rectangular and polar coordinates, but now we're actually looking at equations and converting them. So we're going to start by going from rectangular to polar. So we're not actually using anything new here. We're going to use the stuff from earlier in 10.6, where x equals r times cosine of theta, and y equals r times sine of theta. It is important to note here that your answer should have no x's, no y's,
Mom.
but it should have r's and thetas and maybe even some trig functions. It will most likely be set up as r equals something or theta equals something. So the example, we have y equals x squared. So the first thing we want to do is change our x's and y's using this. So y is actually r sine theta, then equals x is going to be r cosine theta. So that is going to be squared, which means that that's actually r squared times cosine squared of theta. Make sure you're not squaring your theta, you're squaring your cosine because the theta is stuck inside that cosine. I would go ahead and cancel an r out from both sides. And since I do want it to probably say r equals, that is the one we typically go for, I'm going to divide both sides by my cosine squared theta. So now my right side is r. For my left side, I have sine theta over cosine theta, which it may help if you actually split that to cosine theta times cosine theta instead of just cosine squared. Because then you'll kind of remember that sine over cosine is actually tangent, which would leave me with 1 over cosine, which would be secant theta. There's no x's, there's no y's. It's simplified. I have an r, theta, trig functions, those are all okay. It does say r equals, which is typically where we're going, so I'm good. For your polar to rectangular conversions, typically you're going to be using that r squared equals x squared plus y squared. And tangent of theta is equal to y over x. Or you may say, theta is equal to tangent inverse of y over x, since those are the same. Now, that's not to say that you won't use that r cosine theta is x or that r sine theta is y. This is already, in this set, though, is solved for x and y, so it makes it a little bit easier to go from rectangular to polar. You do use them both, no matter which way you're going. For these, your answer should have no r's, no thetas, no trig functions. It should only have x's and y's. Alright, so for example 2, I have r equals 2, which I can't just replace the r, so I'm going to go ahead and square both sides so that it's r squared. I have r squared equals 4. R squared is actually x squared plus y squared. So I have x squared plus y squared equals 4. At this point, there's no r's, no thetas, no trig functions, just x's and y's. Which, if you look at this equation, that is the equation of a circle with center at 0 and a radius of 2, which would look roughly like that. That's the same if I just said r equals 2, because that would give me in every direction I'm coming out a radial distance of 2. So those are the same. For example 3, I have theta equals pi over 3. So I would probably go ahead and take your tangent of both sides, because I know to deal with theta I had that tangent there. Tangent of theta, according to this, is y over x. Tangent of pi over 3, according to my unit circle, would be radical 3 over 2 divided by a half or multiplied by 2. So that would be radical 3. Just to make it a little more proper, typically these are y equals, just like they've always been. So y equals radical 3x. Which, if you graphed that, y equals radical 3x would have a y-intercept of 0. My slope would be radical 3 over 1, which is about that. If I graphed that theta equals pi over 3, I would go to pi over 3 on my unit circle, or wherever. It's right here. And I would draw a line going that direction as well as if I had negatives. So notice that those are the same. The circle here was just to help me get it lined up. It's not part of my graph. The last example, r equals secant of theta. So I don't have anything for secant over here or on the previous slide, and I don't really want to deal with an r squared and a secant squared. So I'm going to rewrite this where secant is 1 over cosine theta. And then if I multiply that over, r cosine theta equals 1. If you look back over here, r cosine theta is the same as x. So I can change this to x. Now I have x equals 1. Which means I have no more r, no more theta, it's just an x. Which is good. On your worksheet, in the back of your notes page, the left side you should be converting it all to polar equations. The right side you're converting it all to rectangular. If you get stuck, I do have the key up so you can check those. Make sure you are trying to truly replace what's there with its x's and y's, replace it with r's and theta. If it's got an r's and theta in it, replace it with an x and a y.